Okay, so I'll kick off today's session. First of all, I'd like to welcome everyone, and I hope you've enjoyed what you've seen at the conference so far. My name is Andy Clark, and I'm an expert services consultant here at aPriori. And I'm joined in the background by my colleague, David Gay. He's a customer success manager. He's going to be moderating the chat. And if we have catastrophic virtual failure, he's going to step in my place and finish the presentation, but hopefully that's not going to happen. Okay, so today's session is on how to track and achieve design to cost targets. Okay, a quick introduction, I'll tell you about myself. My name is Andy Clark. I'm an expert services consultant here at aPriori. I've been working here for just over 2 years. I spent 10 years in industry before coming to work at aPriori, working for the largest oil and gas services company in the world. I was very privileged to be able to work across the spectrum of roles within this organization to see the products being used in the field. As a field engineer, I spent 2 years working offshore on oil rigs installing oil and gas products. I was then transferred to a product center, which is where the products are designed, manufactured, and assembled, which gave me an insight into the design process and the manufacturing process, giving me an enviable position of seeing the entire product lifecycle from start to finish. Okay. I have a mechanical background. I studied mechanical engineering and did a master's in energy engineering. So hopefully all that experience can be relevant to engineering cost tracking. So for today's agenda, first of all, I'm going to be looking at how design engineers can impact cost. Next, we'll look at what the design engineer's dilemma is. So when we look at DFX for X being a particular variable, it might be cost or function or manufacturability. How does the engineer walk that tightrope in ensuring that the balancing act is maintained? Next, we look at the challenges and risks associated with a traditional design cycle, what can cause churn and what can delay commercialization or market penetration. After that, once we've looked at those kind of risks and traditional approach to design, project cost tracking, we're going to look at how aPriori can help you and your organization track cost. Once you have an understanding how cost is tracked, we'll look at how aPriori can help resolve design for manufacture and cost issues using its rich design feedback data. And lastly, we'll summarize how you can develop more cost competitive products faster. Okay, so on to the first topic here. Design engineers really hold the key to cost. It's widely understood that the majority of costs, so just almost 60%, is committed at the design concept stage. So this is the area where you've done most of your physical development of the part. You might know what it looks like. You might have a CAD model. You might even have some FEA analysis done. At this stage, the majority of your committed design cost is locked in. If we walk through the process development, the product development process, we look at the next stages in terms of prototype development. Before you start developing your prototype, you're likely to start layering the support structure for that product development. So you're going to have design drawings, you're going to have any testing, you might have additional CNC programs, or you might have engineering manufacturing routings. And then as you start to get into manufacturing, you start to layer that even more. As you start committing to suppliers, or you're committing to internal facilities. And as we go through this process, is getting, as we stack up the support structure in here, it gets more and more difficult to change. And if we have engineering change orders within this process, it becomes increasingly more difficult and more expensive to make those changes. So even if you're late in the design cycle and you notice a cost-saving opportunity, you might have missed the boat in terms of cost effectively implementing that change. And the stage we really don't want to get to is if we have parts in the market and we have to do product recalls, because that can be catastrophic for any product. An example of this is everyone's probably familiar with is a Samsung Galaxy Note 7, a product that was functionally and technically very, very advanced. However, it got to the market with one fatal flaw, and that's that the battery could catch fire. That resulted in a total recall of all products and actually a shelving and ditching of that program for that product, which resulted in a huge loss for Samsung, both in terms of product investment and also in terms of reputation as a product. So we have to be very careful about how we make changes in the product lifecycle. and what you can do as a design engineer to lock in those costs. Okay, so next we're going to be looking at traditionally how we approach managing design costs within product development. So there's a number of different ways. The first of which is looking at rules of thumb. Typically, most design approaches, regardless of which process you're looking at, will have a certain degree of rules of thumb, a certain way of approaching designing a part for a particular commodity. If we think about kind of a universal one, you typically always want to design parts with, or a product with as few parts as possible. It's less inventory to keep, it's less parts to keep track of, it's less development to do. However, if you get a part that's exceedingly complex or strange shape, it may actually make sense cost-wise to break that down into 3 parts. Okay, so rules of thumb are a good guidance, but they're not always relevant, and there's some outliers for rules of thumb. Next, typically we have design for manufacturer feedback from DFM engineers. DFM engineers are typically a resource with lots and lots of experience in manufacturing and help guide design engineers to make parts that are manufacturable. And typically that is their priority though. They just want to make it manufacturable. They might not be looking at cost optimization, or they might not even have familiarity with the design intent, so might miss opportunities in order to eke out cost from a design. Next, most designers and design engineers have a certain degree of previous experience, experience that they can lean on in terms of developing new product, lessons learned from previous failures, perhaps. But not all engineers have this experience. There's a large degree of junior engineers out there as well who haven't had this opportunity to build that wealth of experience to help them guide their designs. Equally, there might be senior engineers who aren't up to speed with modern manufacturing practices. There might be certain areas that they're not aware of. So there's the ability to miss that optimization there. And lastly, if you really want a cost for your product and understand the cost once you design it, you can send it to a supplier for a quote. However, there's a risk here with sending development parts to a supplier, especially if you haven't told them that you're not expecting to execute on that RFQ in the near term. The customer might get, or the supplier might get upset that you keep sending them parts that you don't end up purchasing. They might give you a no quote. They might send you any quote. They might just give you a number that's of absolutely no use to you. And you might actually end up damaging a relationship with supplier, especially if they're a key supplier, if they think you're just messing them around as a quote generator. Okay. So that's the risks that we have and how we traditionally approach design. So let's elevate this conversation and look at what the business impact is of your part development and any churn that you might have during this time. So typically when a product is developed, you have your initial investment or your expenditure in the research, development, and initial release of your product. So once you've brought your product to commercialization, then you start making sales. Within these sales, you want to be generating a profit. Profit is going to allow you to recoup that expenditure and then eventually turn a net profit. And profit is the lifeblood of any business and an indicator of company health, and is critically important. But what happens if you unintentionally have lengthened your product development lifecycle? You have had lots of late stage engineering change orders, a lot of design churn. You have a product perhaps that is late on delivery and is being rushed to market in order to try and catch the early worm. Or perhaps you are late to market, that product is significantly late to market. What are those implications? So firstly, in terms of expenditure, you're going to have additional expenditure. You can incur more costs during your development due to that churn and all those changes that you're making to your drawings, all that requalification of parts. So there's a lot of additional wages as well that you're going to be paying, incurring additional cost charges. On top of this, you might be late to market and you might miss the opportunity to leverage early market penetration to drive sales and capitalize on the market. There's a good example of this, or should I say, if you're late to market and you have a competitor that is there before you and they get the early market penetration, if it's a similar product, you're going to have to be very persuasive in order to persuade them to change to your product, either in terms of a hugely competitive cost difference or in a functional difference. An example of this is if you look down and look at your keyboard, I'm going to guess it says QWERTY at the top of it. So the QWERTY keyboard's been the de facto design for keyboards for generations now. However, there is in fact a keyboard called the Dvorak keyboard, which has increased productivity. You actually take more strokes on the home bar, which is the middle one, compared to a QWERTY keyboard, which is approximately 32% on the home bar. So you actually have increased productivity on this keyboard. However, it doesn't have that big an impact to everyone that they want to relearn the way that they type, so all that muscle memory. So the same kind of thought process applies to getting to your parts to market on time. You want to make sure that you're there first with a genuine, well-designed product at a competitive price. Okay. So the implications here are that if you're late to market or you have an extended product development phase, you're going to require more investment to bring the product to market. Your competitors might get there first, and you might have a reduced ability to generate profit for the business. And you're probably going to ask, when are we going to get to aPriori? Well, right now, and we're going to see how aPriori fits into this equation. Well, aPriori is uniquely positioned to help customers track development costs and hit target costs on schedule. We have functionality that gives design engineers real-time cost feedback in a feature that they model, whether it's more expensive or less expensive. We give consistent design for manufacturing and cost advice. We have the ability to objectively compare design options to help the design engineer understand which is the best path to follow. And we have the ability also to continuously align visibility to cost targets. And now this is the fulcrum of this presentation today. So what I've done is I've put together a hypothetical situation where I'm developing a product. That product is the plastic commodity parts for a coffee maker, so something we're all very familiar with. And what I've done is I've put together these parts and I've set a cost target against them. Now, aPriori gives you the ability to set cost targets at different levels. You might want to set it, the cost target as at an assembly level, maybe a sub-assembly level, or even a piece part level. We give you the flexibility. But what we also do is allow you to pick and choose the parts that you want to include within that cost target, and we call that a roll-up. It's just a collection of parts. And you can see here on my chart, in the dark blue, we've got the collective cost of those parts, and in the light blue, we have the target cost for those parts. And this is a hypothetical situation, but this is what we want to be following. This is the gold standard of how we want to develop our products, okay? And we can see over time, we've got 4 different time iterations here. aPriori has provided that data and showed that over time, actually your cost for your roll-up in this instance is coming down against the target cost, okay? And we want to be able to track this easily. So what we do is we take snapshots in time. aPriori uses our business intelligence tool called Cost Insight Reports. It's a web-based platform. And what we do is we export the data from aPriori Professional, and then we import it into our business intelligence tool. And we can take snapshots in time and track how our cost progresses over time. So you can see here, I have 4 different snapshots of these collective products. And you can see with the naked eye, well, it's definitely going down. There's less peaks in the second and third and fourth ones as we go through time. But what we want to do, we don't want to only just track the collective costs. We want to be able to see insight into those costs and how they're coming down, and how the engineering manager can help his team to prioritize the parts with the biggest potential to save money. Okay. So we can see here, what I've done is I've flipped the scale. So instead of having a timestamp for the collection, we've got a timestamp or a snapshot in time for the cost of each of those parts. So you can see here, I have all my different parts laid out, and I have a snapshot for each of them. And as we progress, you can see what's happened here is for the parts that represent the most saving opportunities, i.e. the most expensive parts that contribute to total roll-up cost, we've addressed them first. So after this first snapshot in time, you can see that the engineer has gone to look at this part and he's reduced the cost. Again, for this next one, tiered down, we have a look at this third part here. Well, actually, that's had a lot of value engineering done on it already. You know, a lot of the potential cost is out of that. So leave that one as green, no changes. These next ones, though, after the second timestamp on these ones and after the third timestamp on these ones, you can see that the engineers are working down iteratively through the costs of these parts in order to maximize return in your design engineer's time. Okay. So once we understand that we have the capability to track cost and target those parts with the maximum cost implications to your design and your product, we want to look at how we execute to make these changes that help us follow this, this trend here that I've demonstrated. And the first thing we need to do is understand cost breakdown. So design engineers need to try and understand through the use of aPriori how a manufacturing process works and how those costs are broken down. And in this instance, I'm going to use plastic injection molding because in my hypothetical situation, all my parts are plastic injection molded, but also because it's quite a straightforward process. So it's a one machine process typically, so it's quite straightforward. You're always going to start with your material. So once you have your raw material, then you're going to have your conversion cost. And that is the cost of your manufacturing time times by your rate. So your labor and overheads, which are driven by the skill of the labor, the complexity and cost of the machine, and how expensive your factory is to run. Once we have these variable costs, then we start layering in the business costs on top of there. So we have sales, general, and administrative costs. So that's looking at the cost to try and market your product, the cost for your non-manufacturing based personnel, so your executives who are perhaps making the decisions about the direction of the business, and then any administrative costs. And on top of that, we need to build margin, which again, as I mentioned previously, is the lifeblood of any business. We need to be turning a profit in order to keep the business successful. So we need to ensure we have margin built into the product. Next, we consider any investment that's used to generate the product. So in this instance, plastic injection molding, you're going to have your tooling. So typically pretty expensive. And we can decide either we're going to amortize it over the cost of the parts, so divide the cost up of that tooling per each part that's produced, or perhaps we include that as a separate line item on the PO for the purchase of these products. And lastly, we have logistics. And this is typically how costs roll up. Okay, so what I'm going to do now is give a demonstration about how we can get visibility into these costs in our cost Insight Reports platform. So if you'll bear with me just for a moment, I'm just going to swap my screen here, or swap my application, should I say, as I move over to this different screen here. Okay. So I'm just switching over now to the application. And what we can do in Cost Insight reports is we can break down the costs in terms of what I just demonstrated and understand the costs that are related to engineering. For example, you might just be, as a design engineer, you might just be interested in the cost that doesn't include tooling. So you might turn off amortized investments. You might have absolutely no interest in the sales, goods, and administrative costs. You can back out the costs in here through this dynamic chart to understand how your cost breaks down in terms of what's controllable by the design engineer. So we can use Cost Insight reports to give us a really great visual snapshot of how our costs are broken down and give us an understanding of where they come from. What we can then do is work top down in our design to cost out of the box reports, which are available to all customers, and look at the design to cost feedback at a macro level. So we're looking at the parts within that roll up, and we're seeing, well, how do they impact the top level of cost? Okay, so we start here with our top level, looking at these different bubbles. So the size of the bubble represents the spend, okay, and then the color of the bubble represents the design to cost score. So high isn't great, it means you've got lots of features to review. Medium and low, obviously decreasing the number of features to review. But what we're concerned with as well is the size of those bubbles. The bigger the bubble, the more focus we want to pay it. So if I hover my mouse over here, you'll see I have two parts here with a high spend, almost $500,000 there on these products. So we want to target our largest spend first. So once we have this chart here, we understood it, we can try and hone in on the parts that make a difference. Next, what we want to do is go into our comparison screen. So by clicking on comparison here, sorry, give me 2 seconds. Okay, so this takes us into our comparison screen. Can everyone see that? Okay, so what our comparison screen allows us to do is look at the design to cost for each of those constituent parts within the rollup. And now, just as an aside, anyone who's coming to this from a non-plastic injection molding background, don't worry, because for other process groups, we have similar design to cost feedback. So in plastic injection molding, we might be looking at things like draft issues or radius issues that's going to make it difficult to eject parts or cause issues creating your tooling. The same isn't so with the other process groups. We have specific design to cost feedback for the particular process group. Okay. So we can see here, our first summary is of manufacturing issues. So we have hole issues, material issues, radius issues, and draft issues. But again, this chart is dynamic, just like the previous one I showed. So what we can do is, let's say we're early in the design cycle, we haven't applied drafts to these plastic parts. Well, we can back out the drafts and we can see, well, actually, we're mainly looking at radius issues that's driving tooling expense, okay? What we also do in the second chart here is we normalize the number of design to cost issues, because typically on a part with more features, aPriori is going to read those features. And if a part has more features, typically you'd expect the trend that it has more design to cost issues. So what we do is we try and normalize that by dividing the number of issues by the number of geometric cost drivers, or think of those as features of the part. Next, we want to look at how it drives tooling as well. So if you're not amortizing tooling, or even if you have a keen eye on the tooling cost of your product, you want to understand any issues you might have to do with your tooling. So if we have side actions here, slides, lifters, or ribs, again, you can back them out dynamically as you see fit. This gives you an indication of where you have additional costs in tooling. And lastly, you'll notice in plastic injection molding, we have a whole section divided to part thickness or nominal thickness. The reason we pay so much attention to thickness is because it's a significant cost driver in plastic injection molding for the cycle time of your machine. So unlike metallic parts that cool with directly proportional to the wall thickness, for a plastic part, the cooling is proportional to the square of the wall thickness. So a uniform wall thickness for plastic injection molded parts is incredibly important. Because that tooling is driven by the square of the wall thickness. So we need to make sure our wall thickness is consistent, okay? And then what we can do from here is we can start digging into the details even further. If we want to look at particular parts within this subset, we can see here's our chart, okay? We can see where it's being made, the material, we can see annual volume, lots of just the standard production inputs in aPriori, and then give feedback on the issues. What we can also do is we can click on the part to get a particular, even just a visual on that particular part. We can see who's costed it. We can see where it's being made. We can see the production parameters there. So we give you all the way up at the macro level, all the way down to the micro level, real granular input into the cost of your products and the design feedback for your products. Okay. So I'm just going to skip back to the PowerPoint presentation here. Again, bear with me while I change my application. Okay, so I'm back on the PowerPoint here. So this is, again, just showing that how dynamically you can change that chart. So from using these DTC charts, we can identify those high spend areas. So know where the lion's share of the potential savings live. We can identify the next most the next biggest contributor, which is going to be the design to cost opportunity. So we can see, well, this part has a massive spend and also has a lot of design to cost feedback opportunity. So let's prioritize this. So it allows your engineering manager or product manager to really prioritize where his team are focusing their efforts in order to drive down cost and meet target cost. Okay, so from using those charts. So next we're going to look at specific parts, okay? And anyone who's designed a plastic injection molded part is going to be familiar with the design cube, the plastic design cube from Proto Labs. It gives examples of lots of different design options for plastic injection molded parts, both good and bad. And this is a great guidance for any design engineer. But what aPriori does is it turns that that intention of design and applies it specifically to your part. So turning that design guidance up to 11, making it right for the digital age. And we can see here we have a part, and I'm looking at draft issues, and you can see those draft issues are actually painted onto the part. So think of this situation. Perhaps you are sourcing this part. You've made a late stage design change, and actually you've just forgotten to click the draft button in your CAD package. This could make it all the way to the tooling designer, or you know, it could be even worse than that. It makes it past the tooling designer, hopefully not, but you know, and you have a part that you have real trouble ejecting, okay, and you have a huge issue. So what aPriori allows you to do is paint those issues onto the part to really highlight where you could have a potential problem with your design. Okay. Now what I'm going to do is dig a little bit deeper into the different types of feedback we give for plastic injection molded parts. But what I will stress again is that we have design to cost feedback for all our major process groups. Okay, so anything that you see in here, we also have similar for our other process groups. So first of all, tooling considerations within plastic injection molding. We look at slides, lifters, anything that's going to add complexity to your mold, and again that will add cost. We look at ribs, because typically parts with ribs, your material is flowing quite far away from the main body of the mold. The cooling lines for a mold typically don't run down into ribs, so it can cause extended cycle times because your rib section of your plastic part is going to cool slower. Next, we're going to look at wall thickness again, and we want to know if it's too thick and they're going to drive excessive cycle time. Is it too thick that you're going to get sink marks as well? Or perhaps it's too thin and you can have a very, very fragile piece of the part that might even break upon ejection. Next, again, we look at draft issues. We're highlighting draft issues. You can consider draft having a major effect on ejection. So if you don't have draft, you're essentially going to pull a vacuum when you try to eject your part, which can deform it or mean you can't eject your part at all. And that might also lead to deformation, which have a massive impact, especially if it's a cosmetic part. And lastly, aPriori also highlights hole issues. So we look at proximity of holes, which could give an indication of problems with knit lines or perhaps deformation, or blind holes, where you might need a specific pin, which can, if it's deep, you could have issues with that breaking, or you could have issues with deformation again. So now we've kind of had a top to bottom look at how aPriori's design to cost feedback can be used to guide the design engineer and also guide the engineering manager in terms of prioritization. So what this allows us to do is increase product development efficiency. So most people are familiar with the number of changes cost over time, looking at design stages. So release build, traditionally, you wouldn't have had your whole design fleshed out. You test your prototype, come across a few issues, or you build your prototype, see a few issues, test your prototype, more issues. You increase your number of engineering change orders and late stage design changes until you get to your volume production. And again, these costs increase over time. What aPriori is helping you achieve is the ripple effect, where there's always going to be some kind of issue that comes up when you transfer from digital to physical, which couldn't have been foreseen. However, what we aim to help with is make all those engineering change orders and engineering changes early on in the product lifecycle, where you're not going to have a knock-on effect on the supporting structure in terms of manufacturing routings, or in terms of any of your engineering drawings, or anything like that that's going to support the production. But if we change the x-axis here from stages of design and plot it as time, what we can see is the ripple approach actually allows you, excuse me, to come to market faster, investing less money in development and allowing you to save costs. So we look at reducing the number of engineering change cycles late in the development cycle, optimize manufacturing before production, and help you bring products to market faster. The end goal is to reduce costs and increase revenue by bringing more competitive products to market faster with aPriori. Thank you very much for attending today's presentation. My name's Andy Clark. Again, I'm an expert services consultant. If you want to follow up, please drop me an email. My email address is there on the bottom. Thank you very much.
Yeah, thank you, Andy. This is David Gaze. I'm helping moderate the conversation here. So looking through, there are a few questions, Andy, if I can ask you those, that the audience.
Yeah, please go ahead. Yeah.
So one of the questions, some of our products typically take longer to develop than others, given the nature of the product. Can I change how often the cost data is captured?
Yeah, absolutely. So when the data is exported from aPriori Professional interface into the reporting environment, you can set a cadence for your export. So if you know a product typically takes a few months to develop, you might want to set a cadence of every 2 days or so. But let's say your product takes maybe years. The products I used to work with took a long time to develop due to some of their complexities. So you might want to step your cadence down to perhaps every 2 weeks or even monthly in that instance. So there is a flexibility to approach the way in which you set that feedback and understand the cost over time.
Sure, thanks, Andy. The other question is there a way to tag any of the parts that are major parts within the assembly, so ones that are most important?
Yep, so depending on how you roll your parts together, you can use what we call a user-defined attribute. So it's essentially allowing you to tag something. And you can use that as a filter in cost insight reports. So you can have the filter say, I only want to see that part. Or you could do it even rather than having it at the reporting level, you could also do it in the creation of your rollup. So you could have what we call a dynamic rollup. So what a dynamic rollup does is it searches the parts in your database and it will pull in parts automatically with certain attributes. And if you use whatever your flag is as a trigger to pull into that dynamic rollup, then you can just have those parts pulled into that rollup of parts you want to examine. So yeah, it is possible by using user-defined attributes.
Okay, and then I just have a few more questions here, and then I can open up to the audience as well. One of the questions I have is what happens if the cost target shifts during the design process?
Yeah, okay, so that also lives with that snapshot in time. So let's say you go through your product development and it becomes abundantly clear that you're not going to meet that target cost, or there's been scope creep and you have to increase your target cost. The point or the area in which you set the target cost within aPriori Professional can also be changed, and that will be relevant to that snapshot in time. So that allows you to understand at what phase in your development actually you shifted that target cost. So yeah, we do have flexibility to adjust the target cost. It's not an absolute.
Okay, and the last question here, how do you suggest handling if the supplier cost is higher than what the aPriori cost is in the routing? So if you have a target, you've been below that routing, and then you find that the supplier is actually more than the cost we have in aPriori.
Okay, so this is a perfect transfer actually from the work done in design and development into passing on to your sourcing team. So you've already looked through the different routings, assessed ways in which the part can be made, and you want to have optimized that before it even gets to the sourcing arena. And you want to use that information that you've generated in aPriori to support your sourcing organization. You want to give them the data that you've generated. You want to allow them to understand the routing in which you have been guided to use because it's optimized. And that's ensuring that not only does your design meet target cost, but your actual product commercialization and release also meets target cost. The additional benefit to that also is that you can help or guide your sourcing team in using manufacturing simulation data so they can have fact-based negotiations with suppliers.
And I think that's all the questions we have here. Again, thank you everyone for being on the phone. And Andy, any last remarks?
Thank you very much for attending.